Hi guys, welcome to Unit 7. We're already moving on. So Unit 7 is all about polynomials, and we are going to start off by learning how to classify them, add and subtract them. Okay, so let's go ahead and get started. So there's four basic names for polynomials, and these names have to do with the terms, like how many terms are in the polynomial. Okay, so a monomial has just one term, okay? And polynomials, by the way, is just what we've been working with. It's just a bunch of terms. Um, that's what poly means. It's just a lot. And nomial means numbers, so that's really it. So a monomial means one term, okay? And an example would be like 7, 7x, ABC. Those are all a single term. Well, these are three different examples. These are all single terms, so these would all be considered monomials. A binomial has two terms. Sorry, my dog wants to scratch himself right now. Has two terms. So an example would be like 3x plus 2. That would be classified as a binomial because it has two terms. A plus B only has two terms, so we call it a binomial. Okay? A trinomial has three terms. And this is an example of a trinomial because it's got three terms. Okay, and a polynomial, we just use that word for anything that has four or more terms because it doesn't have any more specific name for it. Okay, so it could have 4, it could have 5, 6, whatever. So that one has 4. Okay, so we use these words when we're trying to classify by the terms. Okay, we're trying to name it based on how many terms they have. All right, so a degree of a monomial or term is the sum of the exponents in the term. So most of the time you guys are going to deal with one exponent within a term, but sometimes you see more than one within that one term. Okay, so here's an example. 3x to the fifth, y to the second. This is one term because there's no addition or subtraction signs happening. Okay, but it's got two different variables. So what we do to find the degree is we're going to look at the exponents. When there's more than one exponent, we're going to add them together, and that will tell us the degree of the term. Okay, so this one, we have a 5 and a 2, added together. It is the 7th degree. It has a degree of 7, okay? And that's the degree of the monomial, okay? If we have more terms than just one, what we're going to do is we're going to find the term that has the highest degree, and the one with the biggest degree is going to represent the whole polynomial. Okay, so let's look at an example. So now we have 3x to the fifth, y to the second, plus 9, plus x to the ninth. Okay, so we already found the degree of this one. Okay, so the degree of that one was 7. This term, we just look at the single exponent because they don't have two, has a degree of 9. So we have 7 or 9. Well, of the two, I'd want the bigger one to represent me. Okay, so this binomial has a 9th degree, or a degree of 9. Okay, we take the larger number of the two. All right, now there's another way to classify polynomials, and that is by their degree. Okay, this is not something that you will actually be asked about, but you'll hear a lot of the terminology in questions, in descriptions, and stuff like that. So it's good to know some of these. So a degree of 0 is a constant. It doesn't have any variable to look at the exponent for. Did I have? Yeah. So 7. Oh, I'm moving that. There's no exponent on a variable to look at, so it has a degree of 0. A degree of 1 we call linear because that's basically just one variable with no exponent. Okay? So, and that we call it linear because it looks like a linear equation, like slope-intercept form. Okay? The next one is a degree of 2, and we call that a quadratic. So if you look at it, each degree, if you try to find each degree of each term, 2 would be your highest, so we call that a quadratic. A degree of 3 is cubic, because the highest degree out of all the terms is 3. And 4 is quartic. You can guess the highest degree would be 4. Think of like quarter with it. The highest degree out of all the terms is 4, so that's what's representing it. And then 5 is quintic. And an example of that would be because this one has a degree of 5, and that's the biggest one out of all of them. Okay? So those are how we classify polynomials. The way that we're going to write polynomials, though, is in standard form. So standard form is we take the terms and we put them in order by the degree. Okay? The highest degree will go first, the lowest degree will go last, and that's really important. Ooh, clicked on other things I didn't need to click on. There we go. We'll do leading coefficient. The leading coefficient is the coefficient in the front of the entire polynomial when it's in standard form. Okay, so let's look at an example. For standard form, an example would be this. Okay, you found the degree of each one. So this guy has a degree of 7, 5, 4, a 1, because if you don't see an exponent, it does have an exponent of 1. And then a constant has a degree of 0. And they are in order from highest to lowest. Okay, so this is an example of standard form. This is how you should always write your answer, in standard form. Okay? The leading coefficient, if we look at our example, is the coefficient in the very front of the polynomial when it's in standard form. So this guy's in standard form. We go to the front. The coefficient here in the front is a 4. So the leading coefficient is 4. If there wasn't a number there, there's still a leading coefficient. It's that invisible 1. Okay? Now, to add and subtract polynomials, all we are doing is combining like terms. That's it. We're just combining like terms. So, just a reminder, like terms have the same variable and the same exponent. Pretty straightforward. So here's an example. We have the polynomial 3x squared plus 4x minus 3 plus 4x squared minus 8x minus 9. They're going to put them in parentheses just to tell you, like, this is the first polynomial, this is the second. They have no meaning other than that. Okay? So, I'm just going to go ahead and do it. So, I've got a 3x squared here. Yeah, 3x squared and a 4x squared. So, I'm going to add that off to the side because those are like terms, and that gives me 7x. I have a 4x and a negative 8x. So I add those off to the side, maybe. I know you are clickable. Show. Why does this happen to me, guys? Why does it always want to not work? There we go. So I add those together. It happened again. Oh, I will always have this issue. I'm sorry, guys. I'm trying to go fast. Okay. And I get negative 4x, and then I have another issue. And so I have negative 3 and negative 9x, or negative 9, and that gives me negative 12, I believe. I really should just have this up then. See, you all see that I clicked it. It's just not working. Give me 12. So now I just take those 3 new terms and put them together, make sure it's in standard form. I don't know why it doesn't like me today. It really just does not like me at all. And it's very sad, because I was very nice to it today. Oop, I have to click it again. Click! Oh, goodness, guys. There we go. And that is my answer. It's in standard form, because it's in order by the degree. So, I'm done. Okay? So that's all adding is. Go ahead and try this one on your own. Okay, now example 2, very similar, except it's subtraction. Now, with subtraction, we have one extra step. We are still combining like terms. However, because we're subtracting a polynomial, we need to distribute this negative sign. Okay? So we are going to have negative 9r squared plus 2r minus 1. And then this minus sign, we're going to distribute to every single term behind it. Okay? So now I have negative r squared plus 2r minus 1 plus 5r cubed minus r minus 8. Okay? And now that I've dealt with that distributive property, I can just go ahead and combine like terms. So 5r cubed is by itself. There's no other r cubes. Negative 9r squared is by itself. There's no other r squared. 2r minus r are like terms, so I can go ahead and do that, and I get 1r, or just r. And then negative 1 and negative 8 are like terms, and I get negative 9. So these are my 4 terms. I'm just going to write them in order. So this has a degree of 3, a degree of 2, a degree of 1, and a 0. Write it in that order for standard form, and that's your final answer. Okay? It's pretty straightforward. Alright, so now you guys got one to try on your own there. And here, example 3, we're finding the perimeter of the following triangle. So perimeter just means we're adding the sides. So it's basically, we're just adding the polynomials again. So each side is a binomial. So what I'm going to do is set up an equation. So remember, I'm just doing side plus side plus side. So that's what I'm going to do. And I've got 12b minus 8 plus 9b plus 8 plus 12b minus 8. Okay? So now I can go ahead and group my terms. So I've got a 12b, a 9b, and a positive 12b. Combine those, and I get 33b. And I've got a negative 8 plus 8 minus 8. That will give me negative 8. So those are, I used all my terms, so now I just put it in standard form. So the b is going to go first. So I get 33b minus 8. And that is my final answer. I don't have an equal sign, so I can't solve for anything. I'm just simplifying. Okay? So it's a very, very short thing. So now you guys have one on your own. This one's a rectangle. You could use this formula if you want to find perimeter, or you could do it like triangle, where you're just adding all the sides together. You just need to be able to recognize what these two sides are. Okay? So lots of different ways you can handle this. If you guys have any questions, please write them down. We will talk about them next class. Other than that, I'll see you guys next time. Bye!